Hello, and welcome to Masters with Masters. I'm Ed Hoffman, the NASA Chief Knowledge Officer, and for this week, we're on a special location at the NASA Kennedy Space Center, and featuring a lot of discussions around issues of leadership and change, reinvention, and innovation. And this series is really focused on getting practitioners to share their lessons, their thoughts, and their stories, and to help us to become more reflective practitioners. This particular session is focused on SwampWorks activity and innovative ideas at Kennedy Space Center. And we have Rob Mueller, who is the Senior Technologist for Advanced Project Development in the Engineering Directorate. He's also the co-founder of the NASA Kennedy Granular Mechanics and Regolith Operations Lab. And he's been leading in the development of technologies and innovations for lunar systems and lunar surfaces. We also have Jack Fox, who is the Chief of Surface Systems Office in the Engineering and Technology Directorate. And his office has been involved in science, research, and technology development for surface systems for planetary bodies, their moons, and near-Earth objects. It's a pleasure to have both of you with us. As a matter of fact, what I told you before we got started is this whole week kind of got started when I was here recently at Kennedy. And I had a tour of the SwampWorks facility. I didn't know about it, and I was amazed by the energy, the innovation, and the passion that's going on in terms of trying to do a difficult thing, which is trying to take a successful culture, but tweaking it and changing it in different ways. And that's somewhat been the theme for this whole week in terms of commercial crew, in terms of leadership through the generations, and tomorrow in terms of young professionals. So I'd like to get started with both of you just to ask, how did you get to this point in your career, and how did you start working together?
Okay. Well, kind of the chronology. I started in 1983 in shuttle engineering, and I was on auxiliary power units and hydraulics, and then I moved into orbiter project office. And I spent many years in shuttle, and I got what I feel is a great appreciation for the rigor required for flight hardware processing, that question everything, analyze everything, test everything, because the space environment is very unforgiving and you can't pull off the side of the road if you have a problem. And then in the late 90s, KSC had an initiative to do more technology work. And Rob will probably explain a lot of that, but there were certain areas that Kennedy expertise could find a wedge. And personally, I was assigned to work advanced sensors and integrated vehicle health management technologies, and I led teams that flew flight demonstration experiments on shuttle, and ultimately we incorporated a few of those things on shuttle. And then that program was canceled, and then a series of other similar X vehicles that I worked on, X-33, X-34, X-37, some RLV technology programs. One by one, unfortunately, fell by the wayside, but learned a lot of things. And then I actually worked in external relations for a little while. And then Constellation program started, and I wanted to be part of that. And I did a detail at NASA headquarters in ESMD, and then after that I came back to Kennedy in engineering, and I was chief of the business office, and then very fortunate to be chief of the surface systems office now. So that's the whole thing. So I met Rob during that technology formulation kind of time period.
Maybe tell us a little bit about your story and how you got to this point.
Sure. Well, I've had an interesting career, but I'm just getting started. So I got the big call in 1989 to come work for NASA, and that was right after Challenger. So that was a very interesting time. A lot of people were uncertain about the future of NASA. I saw it as a challenge, and I jumped on it. I was really excited to come up to NASA, and I joined the solid rocket booster processing team. The boosters were made in Utah, and they were shipped here by rail, and we assembled them. And this was a time when the field joint on the solid rocket booster had failed on Challenger. it had caused the accident. So I was right in the middle of the action of fixing that field joint problem. We were developing new methods of stacking and assembling these solid rocket boosters. So it was a good time to be at NASA, and I was with a crew of, just by the nature of wanting to work on solid rocket boosters after Challenger, that was a certain type of person. So it was a good team to be on. And then after a few years of that, I realized that people were sending me instructions, and this was how you assemble it. And I didn't want to be the guy assembling it per somebody else's instructions. I wanted to be the guy writing the instructions. So I looked into that, and I realized a design engineer makes the drawings, and a design engineer determines what the rocket will look like and how these things are configured. So I went into design. I transferred to the design group, and then I started designing ground support equipment because that's what Kennedy Space Center did at that time. I worked on space shuttle umbilicals. I was a lead for the Gox vent hood, which is the beanie cap, sometimes they call it, on top of the external tank. I was a lead for the tail service mass. I worked on the upgrades for the super lightweight tank. I worked on the composite nose cone. So a lot of experience on space shuttle over the years. I also helped design a lot of the GSE in the space station processing facility. So did design for about 5 years, and I was fortunate enough to be asked to go to Johnson Space Center to work on an exploration team under Doug Cook. And then I worked for Doug Cook for 2 years doing exploration studies for the Moon, Mars, and deep space exploration. And that changed my whole career. And at that point, I became more interested in deep space and not ground support equipment. I was kind of finished with that, and I moved on. But I had to come back to Kennedy Space Center. My rotation was over. And we had a group led by General Roy Bridges called the Exploration Think Tank. And so I plugged into that, and we had a group of bright young people that were just focused on going beyond low Earth orbit. And that's how I met Jack. And since then, I've been working on exploration and trying to bring Kennedy into that part of NASA.
Right, so both focused on human exploration, I know both of you for a long time in the different programs, but also a common factor of how do we reinvent ourselves and how do we get more involved in the technology development. So I saw, a few months ago, SwampWorks, and the first thing that hit me walking in was the energy, was the passion, and people, were engaged. It was kind of like on a different, a little bit of a different world, the focus there and the energies. What inspired you to go in the direction of SwampWorks and even calling it that?
Okay, so the agency has been going through a transition, not just at Kennedy Space Center, but overall. And so SwampWorks is a direct answer to the call from our leadership, the Space Technology Mission Directorate and the HEO, the Human Exploration Mission Directorate. They both have skunkworks type of projects, which is Advanced Exploration Systems and the Game-Changing Division in the Space Technology Mission Directorate. So they are asking us to be more agile, more nimble. We're allowed to fail. So we're going back to the future. We're doing things the way we used to do them in the Apollo days. Just a lot of rapid prototyping, a lot of experimentation, creativity, and more at the lower end of the technology readiness level spectrum. So we're just really doing what they're asking us to do, which is the Space Technology Mission Directorate, pushing more on technology development. And to respond to that, we thought we needed a new environment, a new way of doing things. And that's what we call the SwampWorks.
Yeah, and I know it's in the old the Apollo testing facility, and we'll talk about that. Maybe one of the things when I was talking to Jack, you talked about, this is also not just around the technology, but it's also around issues of culture, and how do you reinvigorate the culture, and how do you transform it? What are some of the things that you're trying to do in terms of changing the way we work and the way we do things, and transforming culture?
Okay, sure, Ed. Well, the starting point is KSC has a long history of innovation in engineering and technology in solving shuttle flight hardware problems, payload problems, and a can-do attitude where the rubber meets the road, I think Bob Seek said yesterday. So the easy part was we had a pretty good starting point right off the bat. And so then I came into the group just before shuttle was done, and they'd already been talking about what they wanted to do in this post-shuttle environment. And I was listening to them, and we want a skunk works, and we want lean development, and NASA, it's the new NASA initiative, Back to the Future. And you know, I started thinking, well, let's bring in more people. This is bigger than our little group. Let's make it a KSC thing. And we brought in, there's an innovators group at Kennedy that we brought in, and well, what do you guys want? And it's primarily the young employees, and they're saying the same kind of thing. We want hands-on. We want to develop our skills, and we want to produce things and contribute to exploration missions. And some factoring all of this kind of things in there. And sure, culture change is difficult. Human spaceflight hardware rigor. This is lower TRL technology at this center. So certainly had our challenges in process. Just have to be patient and work through it. And you guys want no process. Well, no, we want right-sized process. We want to be safe. It's okay to fail. Mentality like that, and we're working through that. And I'm seeing change from the grassroots coming up. Different organizations moving up the chain, and a lot of positive change. And there's also kind of budgetary and partnership kind of change. NASA has got to be quicker to do a cost estimate to a customer and get a partnership agreement out like a Space Act.
Let me just jump in because I often hear failure is not an option. That's
I've heard that before.
yeah, that's Apollo 13, right? And it's great attitude. But sometimes failure is an option. And failure is not an option in a mission when you're dedicated to success. But when you're developing the technologies that maybe don't even exist yet, then you have to fail. You have to fail often, fail fast forward. That's our motto. And it's okay. We're creating an environment where it's okay to fail as long as you learn from it, as long as you do it quickly, and as long as you do it cheaply. So yes, failure is not an option when you're going to the moon. But when you're in the lab creating a little experiment, then it's certainly okay to fail. And that's what the SwampWorks is all about.
Right, and so it sounds like it's similar to agile type projects, where it's the kind of a mission where you want reduced cycles because you can learn from what's not going right, what's failing, and just accelerate more effective technologies by tracking that quicker. It sounds like it's about prototyping and maybe simulations and gaming. I mean, what are the characteristics, as you see it, of SwampWorks? What makes it distinctively different than a traditional maybe space flight mission?
Well, it's a creative environment. When you go upstairs, we have an area called the innovation space, right, pun intended, and it's a large area, and there are no walls. There are no cubicle walls. It's just an open space. And this is based on the Silicon Valley model of put everybody in a big room and let them collaborate and just be creative. And we have lots of whiteboards everywhere. And we encourage people to interact informally. So instead of having lots of big, very structured, very difficult meetings where people are tense, we try to create an environment that's informal and relaxed and where people can really interact and come up with new ideas. And so in the SwampWorks, we have a disciplined environment, but we try to structure it so that there's certain locations where you can actually be creative. And that's what it's all about, is coming up with innovation, new technologies, and they might be game-changing technologies, quantum leaps. We're not looking for incremental advances. We're looking for quantum leaps where we actually might have a breakthrough, but that means more risk. So we have to take the risk to have these big breakthroughs, and that's part of the game.
Right. Part of the issue with physical space, also there's a lot of obviously research and a lot of companies devote a lot of money to how do you organize a workspace and how do you have people so that when they go on breaks, they come together, they circle, they talk, and it's a large part of the knowledge sharing activity. So you're trying to capture that. And I know you have a lot of emphasis on young professionals and mentoring, and ask a question about that. One of the things that I think everyone is wondering about is, so how do you change the culture at NASA? You know, it's been around for over 50 years, and it's got a lot of processes, and it's got a lot of stuff in place. And Bob Seek yesterday was saying, I think the most difficult thing was culture, particularly as you go from one program to the next. As you go from Apollo to shuttle, Apollo folks, this is the way to do it. And you know, so how have you gone around changing how you work, and you know, even getting the facility, you know, to do this?
Well, I kind of get back to the basics. What do people want? They want challenging work. They want to make a contribution, and they want to be appreciated. And we try to have a culture of that it's okay to have an idea and share an idea and build something and break something. And just that in itself, I think once some people have tried it, we've had some people come in that were pretty skeptical about it, but within a couple of weeks, they have come up to me and said, you know, you guys are right. You guys are really right. You know, I really enjoy the faster pace, seeing an idea take form very quickly rather than years to take form. So you're getting more kind of gratification of your efforts is part of the culture shift. So, and again, grassroots coming up. And if the facility part of it, it's kind of interesting that I got the whole vision thing and everything, but I got to get facilities and equipment as well, and have to think about the group you're talking to. I might start talking vision, and I just get a lot of blank expressions, and then it's okay. Let's talk requirements. I need lab benches and fume hoods and sinks and AC power, and then they brighten up because they're comfortable with that kind of dialogue of a facility. And so we were able to get the facility that it's all in the timing, and we've benefited from that. There was a lot of momentum toward moving labs out of a building that was off property, so we leveraged that. And we moved back on property, and the only place to put us was in a building much bigger than what we had.
Actually, we were evicted from our lab, and we turned lemons into lemonade, and we actually ended up with a better solution.
I mean, can you tell a story about so you got kicked out of where you were, you know, so to speak, and you turned that? Because, I mean, one of the things that I hear a lot, again, from people in any organization is I have an idea, I want to change things, but I'm being told no. And so they stop. But you guys, and obviously your team, don't take no, you keep moving ahead. So how did the eviction then lead to the new facility? Or
well, first off,
people know you have the
we only
facility,
accept
right?
no the first 5 times. That's kind of our internal thing. That
Right.
What did they say? They said no. Well, okay, that's only 2. You know, we'll
Yeah.
we'll keep trying. So we got the building, and then we learned of its history, that it was the former Apollo Flight Crew Training Building. And I knew of that. And when I was a new employee, there was a lunar module in there as a tourist stop, and went to the archives, and there was quite a storehouse of information on what took place inside and outside that building. All the Apollo astronauts, full EVA suits, lunar module, rover. There was a rock yard out back. They had a simulator. Did full dress rehearsals of their entire missions out there. So we made posters and we put them in the lobby, and that's another leveraging point for inspiration for people, that we tell them that look at the history of this building, and look what we're doing now in this building for exploration, and just a lot of good timing and all of that. And
timing, because you have a lot of, you don't take no unless it's more than 5, and
right.
you know, and you're obviously seeking out, you know, different kind of approaches. One of the obviously technology and the missions we do go across the centers. How does SwampWorks collaborate with other centers? Is there a role there, and how did you get that role, if it is, you know, active?
Yeah, absolutely. Kennedy is not known for technology development historically, But over the last 10 years, and this overnight success has been a 10-year effort. So over the last 10 years, we've been slowly convincing the other centers that we do have a significant role to play in technology development, and most of it is because of our attitude and our experience of having hands-on experience with flight hardware. When flight hardware arrives at Kennedy, many times it needs to be finished or fixed. And so we actually have a lot more experience in that than people give us credit for. And so over the years, we've managed to build this group of technology developers. And as you know, NASA has 10 centers, and the field centers are strong, and they have their own roles. So in order to determine our role, we try not to go into an area that is already being done well by another center. We try to go to an area that is new, that has not been tackled yet, and that way we avoid conflict. And then areas where we do overlap, we try to partner instead of compete. We just pick up the phone, we call them, and we say, we're your biggest fans, we admire your work, we've read all your papers, we've seen you at the conferences, it would be an honor to work with you. And usually,
absolutely. Oh, I'm on board.
Usually that approach is very successful, and we've managed to build strong partnerships where we bring something to the table, they bring something to the table. At the end of the day, NASA is stronger for it.
Right. So it's a collaborative entity. You have clear boundaries, obviously, and it sounds like I'm guessing you also probably are working with like-minded people who want to, again, be innovative, reinvent, create new ways of doing technology. So,
well, I think everybody at NASA is like that.
Right.
At the heart of it, everybody joined NASA because they want to achieve great things, and that's why we're here. The rest is details, right. But we're all here for the same reason, and then we just have to work out the details, and we do that every day.
Yeah. So one of the questions on details, so what are the problems? What are the challenges? Or is it easy and smooth? What are the ones you can tell me about?
Well, in the technology world, you have to have a pipeline of projects. It's competitive. You got to write a lot of proposals, short-term projects, and you got to think about when they're going to run out, and you got to keep the pipeline going. That is very much different from the shuttle culture at Kennedy, of a very comfortable situation of a program that funds a lot of the institution and the people, and but to win things, we need support. We need proposal writers, graphic support, partnership support, like we said, and we're seeing a lot of progress. You know, it really kind of comes down to funding, and Rob had a great our approach. Every time we see a competitor, we make them a partner, and we're doing very well and seeing a lot of progress.
Well, we're also very entrepreneurial. That's the spirit, and you have to be a self-starter. If you sit at your desk waiting for work to come, it's probably be a long wait. What we try to do is be proactive, go out, meet people, make partners, and just we really work it every day. We're entrepreneurial about it, and we try to build our own future. And most of that boils down to writing good proposals and being good team members.
It's interesting because you talk about entrepreneurship, and one of the things I was seeing or I listened to is social entrepreneurship, which is how do you get a new idea started? How do you, in essence, infect an organization and create an energy and all that kind of stuff? What do you see as the skills that you and the team have in terms of that entrepreneurship? And how is it different than perhaps just not having that, but being responsible for a project or a system? What are the characteristics that you see amongst your team? Either of you.
Okay. Well, like Rob said, entrepreneurship, just that get up and go and being outgoing and putting partnerships together. You need all kinds of people on a team. I mean, if everybody was like that, kind of nothing would get done. And then you also need people that project management and the schedules and the budgets and the very diligent kind of work. So We need a whole gamut. And one of our secrets is applied science and technology. So we need scientists and engineers together in these collaboration sessions.
Well, I'm glad you brought that up, because skills and people, that's the essential part of the secret sauce. Is you have to have the skills. If you're going to be a world-class organization and compete, and it does end up being a competitive situation when you're writing a proposal, you have to have a world-class team. And you have to have a principal investigator that's recognized in the community. That's part of winning a proposal. But we need the skills. And for that, we have a new project at Kennedy called Rocket University. And Rocket University is designed. Steve Sullivan is started it, and with a group of shuttle alumni. And the idea is to sharpen the axe, to get the skills to the 21st century level. And so our young people love that, because that's what they were trained for, and they're sometimes surprised when they come here that the older engineers don't have those skills. So we're getting to that point where all the engineers will have the skills they need to compete in a world-class environment, and that's what Rocket University is all about. And we support Rocket University, and we actually encourage that mentality, and the Rocket University graduates come to the Swamp Works, and they can start their own projects at the Swamp Works if they have a bright idea. We give them space. We have an incubator area. We'll give them some lab space, and we'll give them maybe 6 months to a year, and then you graduate.
Okay. And so you're very active, I know, in mentoring, and a lot of focus on young professionals, getting the engagement going and providing the critical access, to people and to work. Why did you do that? Is that the only way you feel you can be successful in changing the culture, or is it giving back, in terms of a new generation? Why the focus on mentoring?
No, it's very simple. It's very simple. In 1969, in mission control, the average age of an engineer was 28. Today, 20% of the NASA workforce is under 40. 80% is over 40. Now that's a kind of a demographics issue, and if we don't inspire the next generation, if we don't get everybody as excited as I was when I got the phone call from NASA, and if there's a lot of things to do today, there's a lot of competition. You could do many things in your life. And so if we want to be the NASA that we are today and that we started out as in the Apollo era, we need to retain the talent, the people. We need to get the best and the brightest into NASA. And so what does that mean? It means you have to have a good experience, because you can do anything with your life if you're smart and educated and motivated. So when young people join NASA, I want them to have a good experience and be productive and be world class. If they can come out feeling like they had a really good experience and they contributed and they gained in knowledge, what more could you ask for? We'll have a world class team and we'll go and conquer the universe.
I want to apply for Swamp Works. What's the definition of age? Is it like 55 and under, or I don't know?
Age is a mindset.
Timeless, right?
Yeah.
It's relative. So we have folks here, and we're open to questions. And are there any questions for the guys here in terms of it, or any thoughts or any comments? Yeah. And so we'll get a microphone, or.
Yeah, I am curious about the pipeline question, how often you get projects in, how rapid the turnover is, what kind of throughput you're getting through that pipeline.
Well, we're still pretty new at the Swamp Works thing. It's just pretty much we never say no at this point, and we just if we get too much work, we've been able to staff it anyway. So it's pretty much furious pace right now. We have a goal of measuring it out and knowing when the annual calls are, and we're getting much more regimented in that regard.
So it's an interesting question, because we have lots of small projects and not a few big ones. I think we have, just in my lab alone, we have 25 projects on the books right now. Okay, so that's a different mindset. You have to work quicker, be more nimble, and some of them die. Some projects die and some survive. It's more Darwinian. And so we operate in this very fast way, and we have whiteboarding sessions. The projects are typically a year in length. And then after the year period, it's an evaluation by a management board, which Karen Thompson, our chief technologist, leads a research and technology management board. We go to the board, and it's like the Shark Tank, and they evaluate our work, and it either passes or it fails. And if it is viewed as a success and aligned with NASA's strategic goals and KSC's road mapping and strategic goals, then it gets approved to go forward, and then we compete for more funding. But it's never guaranteed. Every year is a new year, and we compete for our funding. But it's what we call an engineering meritocracy.
Sounds like it could be a good reality show. Yeah, people pitch their technology,
I've
and
said that we ought to be a
And never a
reality
dull
show.
moment.
yeah, absolutely. Any other questions?
I have one. For those of us who aren't scientists or engineers, give us some examples of some of the projects and the problems that you're trying to mitigate, if you will.
Okay, so our whole lab is based on this concept of living off the land. And when you go into outer space, you won't be able to take everything with you. If the pioneers had gone west, from the East Coast west, they would have reached the Appalachian Mountains and stopped if they had to bring everything with them. But they brought a bucket, a gun, a horse. The horse ate the grass. They went to the river. They got the water from the river. They shot a few buffalo, and they made it all the way to California. So that's the spirit. It's the pioneering spirit, and we have to learn how to live off the land in space. So everything in our lab is dedicated towards in situ resource utilization, and in space, it looks like this magnificent desolation, as one of our astronauts said, Buzz Aldrin. But you have to look deeper. There's energy. There's vast amounts of energy in space, and there's a vast amount of resources. If we can learn how to harness the energy, then essentially energy is free. And if we can learn how to harvest the resources from the regolith contains every element we need. If we can learn how to harvest these resources, then our future in space will be guaranteed, and that's the goal of every technology that we work in our lab. Specific examples, we're mining regolith. We have robots that mine regolith. We have Resolve, which is extracting, it's actually prospecting for regolith on the moon and then trying to find water. If we find water ice on the moon, that's going to be a game changer. So that's another project. We're doing a project where we're 3D printing large structures, 3D print a habitat with regolith, concrete made of regolith. And so that's another example. We have molten regolith electrolysis, where we melt the regolith and we pull the metals out by electrolysis. We have a lighting system which will adjust your circadian rhythm so that in the mornings when you feel drowsy, you turn the knob and the light gets more blue and suddenly you feel awake. And then at night when you're ready to sleep, you turn the knob and it becomes more orange and yellow like a sunset, and something deep inside your genetic code in the circadian rhythm puts you to sleep. So this would be a great advantage on the International Space Station. We've sent a module up to the International Space Station. It's up there right now, and it's altering their behavior patterns just by regulating the light. We have another technology which mitigates dust. It's called an electrodynamic dust shield that actually repels dust just by flicking a switch. Imagine having that on every window in your house or on your car. You never have to wash the windows again. You just flick a switch. And then one of the very new technologies we just started 2 months ago was a graphene battery technology. Imagine recharging an electric car in 5 minutes. That's what the graphene battery technology offers. So that's just a few examples, but we have a long list of other things that are not funded yet.
It's amazing. Yeah, we have another question.
Yeah, I was actually going to ask if there are any specific examples of any projects, but so I guess changing the course from that, what sort of projects, you mentioned you want to keep the young workforce sort of, you know, like you said, talented people who are smart, they're young, they can do whatever they want. So why would they want to come here and work for NASA, or, you know, what could they do? And so what sort of projects do you do outreach-wise? For example, I know there's the Lunabotics or Astrobotics mining competition going on currently.
Right. We have a competition dedicated to robotics for mining regolith. We just finished last week. We attracted 50 universities from 8 countries, and it was just a phenomenal event. And it's based on this concept of if you have a good experience and you compete hard, you can do great things in life. And all these students had, not only did they have a good time, but they spent a semester designing it and learning NASA systems engineering. Then they spent a semester building it. By the time they graduate and they go for a job interview, what are they going to talk about that job interview? I built a NASA robot, and I know NASA systems engineering. I know what a PDR is. I know what a CDR is. One guy came up to me and said, I got a job because I knew what a PDR and a CDR was. That's what you get out of it. We have lots of outreach, and we try to encourage the young professionals to be passionate about what they do and join our team.
Right, the hands-on. Yeah, we have another question.
Just curious about the makeup of your team. Like, how many people are there? What kind of mix between civil service and contractors, that sort of thing?
Well, we have about 20 full-time NASA people and about 20 part-time people right now from various organizations. Contractors, about 10 at this point is where we're at.
I wouldn't imagine, but can people from other centers, hear about this and apply to be a part of this? Or?
Well, yeah, actually, there's activities like this popping up at other centers. And I've had conversations with JSC Space Shop. There's a team at Ames and a team at JSC, very similar objectives. And we've talked about we need to have a federation of
linking together.
And I understand Goddard and Langley have similar things. So if anybody's out there, Goddard and Langley, let me know who I can talk to. And I would like to have multi-center kind of projects going on. And we might even extend it to after hours and do like an Engineers Without Borders kind of an activity. So.
Good. Rob?
This is a push-pull effort. The STMD is pulling from headquarters, trying to extract good ideas from the workforce and make game-changing technologies. And then there's a push from the grassroots where people are demanding satisfying work. They're demanding that they be given access to a machine shop to go make a prototype. They're demanding 3D printers. We have 3D printers in our lab. Anybody can go there at any time of the day and print out a part that they need for their project. And so we're empowering the workforce. We're empowering them to use their intellectual capacity and create new ideas, and so that's the push part. We have to create an environment where people can do that. The rest happens by itself.
Right. And obviously this is a component of a larger center and a larger agency. What's your vision for how this impacts NASA as a whole or Kennedy as a whole? I'm sure you have thoughts on that in terms of how do you want to impact the culture and the organization?
Well, similar to what Rob just said, I think we establish the capabilities in the process, and it will happen. Just the natural course of events, people will make contributions. Now, we are very roadmap focused and exploration architecture aware. We're trying to plug things into the architectures. We're trying to make leapfrogs that make them rewrite architectures. And our kind of purpose as a government lab is this iterative design where you build, test, learn, update the design. Then you get to a point where you hand it off to industry, perhaps, that they do the very detailed systems engineering and make a flight article. So we very much have an eye on wanting our things implemented in NASA architectures and commercial space architectures. Also, always thinking about dual-use technology. There's definitely things that we're doing that we would like plugged into applications on Earth.
Right. Yeah, I mean, it sounds like the examples you gave, like the sleep, would be not just important for a space station, for a lot of us here. And so I would think there'd be businesses that'd be interested in some of the technologies. How do you make that connection, or do you? Is that a different part of the organization that works the technology exchange?
No, we have an active organization that does technology transfers led by Dave McCufka here at KSC, and it plugs into the agency-wide technology transfer. One of my favorite documents that NASA publishes every year, I wait for it every year, is the spin-offs catalog, or NASA spin-offs, and I love looking through that. It's a catalog of innovation. And so we try to plug into the NASA system. So what the typical process is, you have a good idea. What should you do? Well, first thing you do is you write a new technology report, an NTR, and document it so that if it is patentable, you get credit for it. And so we encourage everybody to write an NTR right away. And then we develop the idea further, and there's a defined NASA process for turning an NTR into an intellectual property claim, which can end up in a Tech Briefs article, or if it goes further, it could end up being patentable. It just depends on what it is. But we work closely with our Tech Transfer Office and our legal counsel to do the right thing in terms of intellectual property. And then the end result is for NASA is that they can license these technologies and get royalties back to the government, which benefits the lab that developed them because the royalties actually are redistributed and reinvested.
I would imagine with anything new and innovative and doing things, you probably have had to deal with some criticism. How do you deal with criticism or obstacles, and are there any things that have come up that you've had to deal with that you would recommend to be aware of to young entrepreneurs starting the same thing?
Well, you have to be resilient and just kind of go with it. Guy in our group, Mike Galuzzi, said, when you're getting near the target, that's where you get the most flack. So I think we're pretty near the target. and I always tell the people that just keep producing, that's the ultimate feedback. When customers are liking the products, they're giving you more work, they're writing emails to your center director about you, that's what's important, are the products we deliver, and that definitely softens the criticism that you have to deal with.
Moving forward.
Right.
Deal with it.
So I think how I deal with resilience is that you have to have a vision. And so there's a vision for humanity, there's a vision for NASA, and there's a personal vision. And if you can clearly visualize those three things and how they interact, those are your guiding rules. Everything else is your environment that you're operating in. But the vision doesn't change, the environment changes. And so you have to be smart enough to negotiate the environment that's placed in front of you while still maintaining the vision and reaching your end goal.
Would you be willing to share either your personal vision or the vision you feel for NASA?
We've been, Dr. Phil Metzger and I and Jack and others in our lab have been working on a vision. It's a resource-based vision of expanding humanity and human civilization into outer space. So really at the end of the day, what most people want is a better quality of life. That's really, it's Maslow's hierarchy of needs. Says first you want a roof over your head and some food and some water and some shelter. That's the first thing you want. But as humanity evolves, you want more. And you're not satisfied with the basics. And so that's where, as a civilization, we want a higher quality of life. I always joke that 20 years ago they said computers will become more efficient. Why am I still working 5 days a week? Why am I not working 4 days a week and I have Fridays off? Because I'm so much more efficient than I was 20 years ago, right? So why can't we do that with humanity? Why can't we, what's our biggest constraint today? Energy. If we solve the energy problem, we can become greater architects, we can become greater artists, we can do better science, we can have better leisure. It's just quality of life. So how do you achieve a better quality of life? Well, if you look at the history of mankind, it's usually related to resources. There's actually billions and billions the amount of resources in space than there are on Earth. So with the abundance of resources and energy, our lives will get better. But we will not be able to harness those resources unless we harness the space technologies which will let us go use the resources in space. That's the catch. We have to use the resources. They're there, but we have to figure out how to use them. But at the end of the day, we want to improve our quality of life as a human race.
Right. So you have a very clear-cut vision, personally, for the organization, for society. Sounds like you link it to the strategy, obviously, of the organization, or you don't have any support, and that strategy then plays out in terms of different projects and approaches and goals.
Of course, we're lucky because NASA is largely aligned with this vision of improving the human condition that's in the NASA strategic goals. So all we have to do is now align ourselves with NASA strategy, work with, one thing I do want to say is, which we didn't mention earlier, is one of the reasons we created SwampWorks is we have to do more with less. The budgets are going down. So if you keep the status quo and you keep using the processes and systems and programs that you have today with reduced budgets, you're setting yourself up for failure. So by definition, with reduced budgets, you have to change something. What we're trying to do is invent new methods to be more productive with less. And that's another good reason for starting a SwampWorks.
Yeah, one of the principles, obviously, is to be lean. And so it sounds like being lean would be not to have too much, paperwork or digital, technology capturing things. But you're also doing something very new, and you obviously have lessons. You have things that you're learning. How do you capture that, or do you capture that so whoever's doing this in 5 years or someplace else can learn from that and trying to impact their organizations, or do you not worry about that?
No, well, like Rob said, we've got dozens of projects, and we have a project manager that helps the PIs, and part of his job, Luke Setzer, is he establishes our SharePoint library of the proposals and the project plans and the lessons learned, and also publishing. A big thing for us is it's a requirement. Publish your work and keep a library of that, so we don't have to reinvent. Did we ever do that? Or we have a place to go for the next people to come through to refer to.
You have an approach to keep that, and also I guess one of the benefits of you have young professionals, you have different folks who, in theory, hopefully would stick around to be able to transmit that.
Well, this is a very interesting question, this knowledge capture question, and what we're trying to get to is traditionally you do a project, then you stop and you write a report. What we're trying to do is take advantage of the new information technology where you never stop and write a report. It self-documents itself as you go. And that's possible now because of the how cheap memory is. You can now you could film your whole life every day and store it on a hard drive. Now the problem is information overload. So we have to find a balance between capturing too much and not capturing enough, but also we're working towards a system where our processes allow us to self-document as we go. And right now we use SharePoint, but there's probably better tools out there. But we do try to knowledge capture as we go so that at any given point in time, all the information is available.
That's excellent, yeah. And the technology is so readily available that it blends itself into what you're doing. Yeah.
I just had a quick question. How can everyone here get involved in the sort of concept you're speaking of and the organizations that are cropping up? And do you hope to sort of serve as a role model to have other organizations, maybe not NASA affiliated, but I guess in society in general, to crop up and do this same sort of thing?
I think there's a movement out there. It's called the Maker Movement, and they're doing exactly what you're saying. It's not unique to NASA. Everybody's doing it. It's part of the whole social networking phenomenon. It's empowering the normal citizen to build things. So that's already happening. How you can get involved as a NASA employee is there's a couple of ways. We have this program called Kickstart. So a couple of times a year, we advertise the Kickstart. And you can come and present any idea you have that benefits NASA. And if the board, there's a board of directors, some of our senior management that listens to it, if they decide it's worthy of some funding, they'll give you $5,000. And if your supervisor agrees to allow you to use your time, then you can spend the next 6 months with a $5,000 budget and some of your time to go develop your idea. And then you present it to management again, then it has the potential to become a real project. That's one way of doing it. Another way is to join the Spaceport Innovators Group. It's a group of young professionals, and actually not just young professionals, I'll call it motivated professionals, who meet once a week, and they invite speakers and they discuss ideas. It's a think tank. And so that's another really good way of getting involved, is through the Spaceport Innovators. Jack, you have anything else?
Well, and as far as working in the Swamp Works, we haven't formalized anything, but if you have an idea and we think it's of merit, we would make sure you were trained to come in there and give you a little incubator space and help you produce your idea.
Yeah, one of the things we can also do in terms of the Chief Knowledge Office is we can place, some of these sites that you've referenced to make it available to folks with whatever you're comfortable with, and we can also put it on the APPEL, website, so it's out there. Yeah. Yeah, no, very good, good discussions. I mean, one of the things that you started with, I think, was failure, and organizations that are around a long time, they sometimes get resistance to, to going in a new direction. Do you have an example that you like to talk about in terms of where something didn't go as planned, or where you can classify it as a failure, but that led to, just a breakthrough and improvement?
Well, it's only failure if you don't learn anything. So we never actually say that was a failure. We've got a few. You got one you want to fuss up with?
What you're looking for is a Post-it note, right? The Post-it note was a failure. It was a glue that didn't stick very well. And so a whole new business was developed out of the glue that didn't stick very well, and they made Post-it notes. I will say that the regolith is a strange substance.
What is the regolith? I'm sorry, I don't.
Regolith is crushed rock. It's the loose surface material on a planetary body. Has no organic material in it. It's like soil, but has no organic material. It's basically crushed rock. Right. It's formed by meteorites that impact events on planetary bodies, and over 4.5 billion years, it's created a lot of small particles between 20 and about 80% are between 20 and 100 microns in size. So it's like beach sand, but much finer. It's like a crushed glass talcum powder. So this is a very interesting substance because it behaves like a fluid, but when you compact it, it behaves like a solid. So it has this binary state. So we're thinking that if you can somehow harness that property where it behaves like a fluid in one condition, and then you simply turn on a little vibrator and it compacts it, now you have a solid state. So that's kind of like a thixotropic fluid. When it's under shear stress, it behaves like a fluid, and when it's under shear stress, it's like a paint. It doesn't shear as much. So we're looking at those serendipitous properties where we can make something out of it. Maybe that's an example of what you're trying to say.
No, that's very much so. One of the things, we're coming down to the final, few minutes, and one of the things I wanted to check, with both of you is, at the core, you're about an innovative place that has passion and energy, and people are doing cool things, and that motivates and goes in a direction. How do you create that kind of a innovative office, environment, workplace? What is it that you do as managers, leaders, as engineers, as technologists to make that happen?
In my career, I've always seen the group takes on the personality of the leadership. I mean, if the leadership is kind of negative, they all kind of become negative. So I very much think it's lead by example and try to keep a positive attitude and, frankly, work ethic and roll up your sleeves and no job too small kind of a thing, and the people catch on to that, and it's infectious, very much so, I believe.
So innovation is nothing new, and this has been studied. There are courses that are taught on innovation. There's actually a process for innovation, and the process for innovation first starts with creating an environment which is conducive to innovation, and it's both a physical environment and a psychological environment. So first you have to create the correct environment for innovation, and that's what we're trying to do with the SwampWorks facility. Once you've created that environment, you need the skills. Then you put in the people with the right skills, or you grow the skills. Then you let them go nuts, and you brainstorm. And that happens for a while. We call it controlled chaos. Then the management steps in, and the adults take over.
Jack steps.
At a
You're
certain
the
point,
controller of chaos.
at a certain point, you have to say, stop, enough brainstorming, now produce. And then we have to pick a concept and go with it. So there is a process to innovation. The trick is to create the environment where that process is allowed to work.
Yeah, it's been fascinating. I know we're coming up to the close of our time, and there's a lot of key things. And again, when I had first toured, I didn't know. I got calls when I come here from different folks and say, "Have you seen swamp work?" It may have been Steve even. I said, "No, I don't know what's the swamp work." I assumed it was something with alligators or something. I didn't, it wasn't communicated. And then, of course, I've known you for many years, and we went over there, and it was amazing. But you do see the energy, and you see the passion, and then the different technologies being worked are amazing. So you've been able to capture something. I think that's very important. And when I came out of that, I called Lewis Peach and said, we got to do a Masses with Masses and ask, because in so many places you'll see people who you can get down in terms of looking, backward, or how are we innovative? How do we change the culture? And I think you've clearly demonstrated there are ways of doing that. And so I appreciate you taking the time to talk with us, and look forward to a continuation of that. And also want to thank, in terms of the NASA Kennedy Space Center leadership, obviously Bob Cabana and Lisa Malone and the Public Affairs Office, who've been phenomenal in terms of supporting us, and NASA TV, and our Chief Knowledge Officer here at Kennedy, who's Michael Bell, and also the producer for this series is Lewis Peach. So everything has really floated beautifully, which often doesn't happen. But it's been a wonderful story, but it's been fascinating. It's so important to keep this going. And thank you all.